So we just said that it is really important to choose your system very carefully before we apply conservation of momentum or impulse momentum theorem. And we'll consider three cases here. Case one, the system is the ball alone, only this. So we just have this ball to be the system here, right? Only this ball, not the hands. Only the ball to be the system. Now, when the ball is the system, the force is applied from the hands, right? So, like this, the force is applied from the hands onto the ball. So, there is an external force. And what is the origin of that force? The origin of this external force is the hands of the boy who is external to this system of ball alone. And therefore, the system is not isolated and you cannot use conservation of momentum. Instead, we'll have to rely on impulse momentum theorem. Okay. So if the ball only is the system, considered to be the system, the hand and the corresponding force that comes from the hands is an external force. Therefore, conservation of momentum is not applied. Okay. Now we have case two, which is what if the system is considered to be ball along with the boy? Ball along with the boy. Now, the ball and boy are now part of the same system. The hand is part of the system, so the force that is arising from the hand is now internal, which means if we draw the system, it would look like this. So the force that is arising out of the hand on acting to the ball is within the boundary of the system, and therefore is now internal. But the ground exerts an external horizontal force, which is the friction, to stop the boy from sliding back when he catches the ball. This external force breaks the isolation. So again, momentum is not conserved. You still have to use impulse momentum theorem to analyze the ball's change in motion. So it would be better if you could just go through one diagram here. So if you consider ball and the boy here, this arrow here represents weight of the ball, force acting on the ball due to the man's hand, and we have weight of the boy acting downwards. All these forces are internal. The only force that is acting from outside, the external force, is the friction, because friction is acting on the boy from the ground. So the ground here is not a part of the system. Why? Because the system is considered to be only with ball and boy. So are any external forces present? Yes, the ground, not the ground reaction. My bad, this is wrong here. It is not the ground reaction which is the external force. It is instead the force of friction. And since an external force is acting, therefore we cannot apply conservation of momentum, and we'll again have to use impulse momentum theorem in this case. And now comes the important one, which is case 3. The ball is in boy's hand, but the boy is not on the ground, but is rather on the ice. So ball plus boy on skates or ball plus boy on ice. And therefore the difference between ball plus boy on ground and ball plus boy on skates. Oh, sorry, this. So again, ball plus boy is one system. The hand force is internal. Now the boy is on skates or ice. There is no horizontal external friction, which of course practically means that friction is almost equal to 0. Now the system is isolated very specifically in the horizontal direction. Now we can use the conservation of momentum here. Initial momentum of the ball will be equal to final momentum of the ball plus boy. Why? Because we consider ball to be at rest in the beginning. So mass of ball into velocity of ball, initial velocity of ball will be equal to mass of ball plus mass of ball into final velocity. The ball will therefore recoil backward slightly after catching the ball. Why? Exactly, it would be to conserve the total momentum. Okay. Now, yes, I do understand there might be a couple of questions that come straight into your mind right now. I try to solve it, some of them right away. But if you still feel that my explanation puts you in a lot of leading questions, please feel free to ask. I'll be more than happy to reach out. Okay. So one among this is you might be wondering, is a normal reaction an external force which is acting on the boy? Well, in fact, it is. So we have one force here, force represented by this arrow here, the force of gravity, which is mg of the boy. And there is an external force acting on the boy from the ground. Normal reaction from the, sorry, not the ground here, from ice here, normal reaction from the ice. Yes, it is definitely external. But the point here is this external force is balanced by the gravity, and which is the fact why he's able to move around the horizontal force, horizontal surface. And also, it is not influencing the motion. Which motion? The horizontal motion. What about friction? Friction is actually acting in the horizontal direction, which means it is an external force acting in the horizontal direction and therefore influencing the motion in the horizontal direction. But the friction is so negligible that F external can be considered to be zero, and therefore, momentum is conserved. Okay. So that is something I want to tell you about. Conservation of choosing between conservation of momentum and impulse momentum theorem. So always make sure that you understand which theorem, understand the choice of theorem is based on selecting the system, and therefore choice of system becomes crucial while you solve questions. Okay. Right now, this a very similar question: a boy catching the ball.